Hi, this is Alex, co-founder and CEO of the United Manufacturing Hub, and we are today here with another episode of the Connected Factory podcast. Today we have, as usual, a very special guest with us, Tilman. Tilman is at BCG and he's partner there, and there drives mainly the Industry 4.0 topics. And he is a technical guy, so he is, in his previous role, he was also CTO, and therefore can really translate these technical problems and architecture challenges into business value. And perhaps you can shave off some sentences that you can use to pitch why the UNS is important to the management. And yeah, let's get straight into it. Hi, Tilman. Great to have you here.
Hi, Alex. Nice having me.
It's actually a really special episode for us because now we have like this technical podcast and now also like swirling in a little bit the organizational aspects of what's really needed. And I think you're really a great person to talk about that. Can you shed a little bit light where you're coming from? So you know, at BCG and what led you there?
Sure, happy to do so. So as you said, I'm a partner with BCG, 10 years with the firm, but my background is in mechanical engineering. I have a PhD in automation control. So spent most of my time dealing with automation tech and developing software on the shop floor and for the shop floor. And actually, I live between the IT world and OT world and have the pleasure to work with a couple of companies out of the manufacturing industry, but also pharma industry, and help them actually to develop future-ready architectures and designs for their factory of the futures.
You have been CTO in the past, yeah? So you're really in the trenches on technology. What did you do there?
Exactly. So I had various CTO-like positions in various tech companies. After graduating my PhD, I joined a couple of internet companies. So at this time, this was very much about how to develop mobile applications. And so before I gained experience in industrial control technology, so it's a pleasure to gain different experiences with different type of software stacks, from today, edge computing to industrial control technology, to back-end technology, cloud computing. At the end, a broad spectrum of languages and architectural pattern to solve problems.
So really, really wide technology scope that you actually have been exposed to. So really, I would say this perhaps a little bit dusted automation control space. I think there's happening a lot with virtualization and DevOps also on the shop floor. But in contrast to mobile and cloud native applications, I think a wide stretch. So, and what do you see there, like in the automation market? Is something changing there, or how do you see that space?
Yeah, absolutely. I think that both of us, we also claim, let's say, that automation tech is turning into a software-defined automation world. As you said, topics like virtualization, container technology are building or paving the way towards a really software-defined automation world, where in future...
term, there's a company like that, and who founded the term SDA? Did you settle on that with Joseph or not yet?
Yeah, I think it was a kind of coincidence, or both of us had some thinking about this terminology. At the end, I think it describes the fact quite well, right? So everything is turning into software, and that's also true for automation technology. And I think also from an economic point of view, it makes sense, right? Because you have a much better utilization of your compute power if you are capable to manage your OT as you manage your IT. Yeah, I think at BCG, we claim this sometimes also as a data center operating model for the shop floor, because I think the OT world can also learn a lot from the IT world. Yeah? So how we manage compute load in the IT world, if you try to think of this pattern and apply this to the operational technology, it totally makes sense. For sure, we need to deal with different latencies in the OT world than in the IT world. But if you can overcome these challenges, and I think it's technically feasible today, there are great references and examples. Look what Henning Löser is doing with Audi, for example, in this regard. It's doable, yeah? So the future will be a software-defined automation.
Definitely. And I really think I had a similar discussion with Velux a few podcasts back, and he also said there's like so much free knowledge in the IT space that can be just copied with pride to automation. So it's how we deploy software, how do we package software, how do we create high uptimes, how do we harmonize, so like or centralize firstly and then harmonize software. And there's often this, I would say, OT perspective on, but IT is built differently. It's built for high user, high volume, and we are building for safety, and reliability. And this is often not an easy discussion, but it's moving into each other, I guess.
Agree. My experience is that what prevents companies from really turning their automation or shop floor system into a software-defined system is, on the one hand side, it's not as easy to deploy software in the OT world as in the IT world. So this whole continuous development and deployment idea, I think, which is like one of the key sources to innovate at the speed of software, which is really well known in the IT world. This is something we strive for in the OT world, but the existing network topologies, you mentioned topics like cybersecurity, but we need to deploy, let's say, across different levels of edge gateways, for example. And this is way more complex than in the IT world. But I'm fully convinced once we solve this problem, we can really unlock a lot of potential and a lot of value. But as of now, based on our experiences, is really one of the key things which prevents companies from unlocking this value.
I think there's also some technology misuse, perhaps a little bit too harsh, but it's like we want, for example, Kubernetes on the shop floor. We want data streaming on the shop floor. We want like high availability on the shop floor, but then we want to have it air-gapped. We cannot have SaaS applications, and like cloud applications or like cloud technologies are not built in air-gapped scenarios. So you directly crank difficulty to super hard. And I think there needs to be like a better, like everything needs to be in my private container registry. Everything needs to be air-gapped. It can only like manage updates in that specific way. And then you make everything so hard. So it's also a change management process on architects that needs to happen.
Yeah, fully agree.
And I think this is the one side, the enabling platform that you need. So like technology, cloud native on the shop floor, scalable, reliable, and also powerful for the future use cases. And what's this is your take on that? So how should you approach like and to pitch it to your peers and your coworkers that you need such kind of technology when they're specifically more interested in the use case and the bottom or top line savings or upside?
Yeah, I think if someone is talking to the both of us, so we are very enthusiastic in technology, right? So it depends, as you said, a little bit on the audience. Yeah, I think when you approach decision makers or C-level people, with all respect, but I think they do not judge mainly on technology. Yeah, so they really care about what kind of value you can unlock, also how to scale certain use cases. Yeah, so this is actually the kind of thinking which drives their decision making. And so to be clear, I think it's not so much that you can convince these people with a seminar about industrial data management. It's more like you need to showcase value leakages on the shop floor, how you can solve dedicated problems, how you can start automating things which you couldn't automate before, and you need to showcase and give good reason why you are now capable to do this. And once you are capable to communicate and to make this tangible, that people really see and feel it, then you can change also their perspective on certain things. Then there is a kind of willingness first to give you time that you can explain, but then also to take decisions. Because as we discussed at the very beginning, it's a very complex topic. And normally you don't have time to explain in detail a complete architectural design and to explain the pros and cons. So we need to derive this actually first and foremost from a company strategy. So the whole architectural design should also be in line with a company strategy, because the company strategy also explain like your ambition level. Yeah. So how ambitious are you? When we talk about a future-ready architecture, what does this mean for you? What kind of automation level are you striving for? And then, if this is in line with your business goals, with your business strategy, then we need to understand and clearly articulate what are the value leakages and translate these value leakages in concrete use cases. And then out of the use cases, we can derive technical requirements, which we then design into a proper architecture. So this 3-level approach of having a clear strategy in mind, which each and everyone in the company is aware of and understands and is working in the same direction. Secondly, unlock value leakages. So really explain where the value is, explain how to scale this to really unlock the full potential. And then last but not least, derive the technical requirements on an architectural design.
also way nicer to position. This is the business goal, this is the ambition level. We really want to have this, and this use case covered to take that value from the table. And therefore, we need a high available architecture. We need like an easy to deploy solution. And I think this then resonates way better with decision makers, which are not as technical as you are. And now zooming out, like there's like not directly, it's a recession all over the world, specifically in automotive markets. What is currently top of mind? So there was this AI, or there is this AI hype train, still not full steam. I would say it's a bit down. But what is now currently top of mind? Perhaps is it that we actually need the data to power those AIs? Is it that we need to have the right organization, upskilling? What do you think is currently specifically in the technology sector, in industry, it's top of mind?
Yeah, so good question. What I see at a couple of clients is most or all of them gain, let's say, experiences with certain lighthouses, right? So they identified use cases, they implemented the first use cases, but there's also a little bit of a downside of this because the expectations of Industry 4.0, for example, was way bigger than maybe the impact they can measure as of today. Yeah. And this brings us a little bit back to what we discussed previously. The reason why they cannot scale is the missing underlying architecture to really deploy software. Because it's not as easy as it sounds like, hey, we develop the famous predictive maintenance application and then we just press a button in the same manner as we download an application on our iPhone to deploy this into an architecture of your factory. And this is something what people need to understand, what it really takes to develop, to manage, to deploy, to maintain software on the shop floor.
Yeah, and I really think it's also perhaps a change of audience also that's needed. I think this 2017, 2016, this was the Industry 4.0 hype train time, where it was at full steam, and then it was often push all data to the cloud, and then all our problems are solved, and then we build solutions in the cloud. And what I saw in the last years is actually the change in audience. So it's not the data scientist that develops use cases. It's actually often like the maintenance guy, the automation guy, the electrician, or whatever who is really exposed to the shop floor problems, who needs a tangible solution to really solve his own problems fast. And this is really the enablement factor. Yeah, this is perhaps where some architecture deviations or like reworks are currently under progress to really upskill and enable those people, rather than just having it there and then the abstract data scientist will take care of all my problems.
Yeah, I agree. And I think this is, by the way, also where you guys come into play with your solution, because what we also see is it's on the one hand side, you can invest the effort into building a first lighthouse, but over time, you need also to showcase that you have that your approach scales so that you can benefit from economies of scale. But the difficulty in today's way how we implement these solutions is, for example, that if you develop one use case, let's say a predictive maintenance use case, which needs certain industrial data, then you follow up with a set point optimization use case, with a visual quality inspection use case, and all of these use cases needs to have connectivity. All of them needs to have industrial data. So the way that you replicate again and again this complete, let's say, plumping of industrial data to your application doesn't scale. Yeah. And I think this is also one of the reasons why the effort is way too high today to do it. So very strong economic reasons. And the reason or the idea to establish something like a middleware in between, which abstracts actually and exposes data to an overarching layer where you can connect to with your use cases, I think is exactly what's the missing piece.
Yeah. And it's also like I said, tied to economics. It's like really getting the cost per use case down. It's like one thing to like spend a lot of money on one digital lighthouse, but it has obviously huge overhead and system integration attached. But it's something to attack the long tail, and specifically in the long tail of small use cases at a wide stretch and a wide exposure, there's actually the value to be found. And therefore, data needs to be a commodity. So like electricity, like pressured air in some industries, it needs to be also data needs to be easily exposed and to be consumed and to be acted on. And this is the unified namespace, perhaps, and not it. it could be a buzzword, but I think it's actually a good term to describe what we are doing. Yeah, it's something that's already been out at the name, and it's an event-driven architecture, and also on the shop floor. And what's your perceived perspective on a unified namespace? Is it something that already resonates in the management spheres, or is it too niche yet?
Well, I think the term unified namespace is maybe not so well known in the industry. So you really need to talk more to very technical people, that people are aware of this term and what it really means. But once you explain this, so what is the benefit from it? Exactly as we tried to explain this previously, yeah, so that you can benefit from economies of scale, and that you can lower down the implementation cost because you try to establish a kind of middleware, a unified namespace for each and every application on top of it. People start to understand, and absolutely they see the value in it. Why? Because they experience how it is today. Yeah, and that kind of peer-to-peer architecture where you connect each and everything with each other, you could also illustrate this quite nicely and quite easily. Yeah, and make totally sense that a hub and spoke architecture maybe makes more sense. So with these easy illustrations of the current architectural design and the future architectural design, you can convince people and at least make them think about, okay, the way how we approach it as of today, maybe we need to rethink this. Maybe there's something we need to take into consideration. For sure, it's, let's say, an additional level of complexity on a first grade, because you introduce, again, another piece of software, another middleware. But I think on the mid to long term, it totally makes sense because it really helps you to start scaling and deploying your use cases. And one last word, I think in many conversations, in argumentations, we focus very much on one use case in one factory. But the reality at large-scale companies, so at enterprise companies, they need to manage hundreds of plants. So it's a way bigger problem. So if you explain like a really enterprise company, hey, we really want to deploy a set point optimization use case, you need to explain how you deploy this across 100 or 150 or 200 plants globally. Think of, you need to do this manually. That's impossible.
It needs to be elastic, yeah. So even if you have like a template or use case, like the reality of the shop floor, it's built through mergers and acquisitions, like it's so different. So they could not even agree on an MES system in most cases. So how should they agree on one API to power all the use cases? So there needs to be this flexibility to really make it scale. So beyond technicalities. One important lever that's then also in the mix, it's we as technical people also love to build, yeah. So like, we have a problem, let's throw architecture and components and more on there. And I think there was a little bit of a mind shift in this build versus buy approach. Shall I now build or buy such a middleware? What's your take as a management consultant on this?
Yeah, as always, it depends. Yeah, so it's a little bit depends on the, let's say, DNA of the company. There are companies out there who also in the past invested very much into their technical capabilities. I personally know people in companies who have absolutely the technical skill sets to implement this by themselves. Maybe these, I call them sometimes like the do-it-yourself type of companies who are capable, maybe sometimes use also or in favor of open source technology. Yeah, so they are capable to do this, but there's a huge but. There are also companies who understands and argue, hey, that's not core of our business. We do not need to invest and build up these capabilities to do this by ourselves in the same way as you do not develop your own Microsoft Word or PowerPoint application only because you use it every day. And so there's a good reason why you should rely on professional software. So my answer would be, it depends a little bit on the background of the company, but I think the majority of the companies, they would prefer actually to use it as a service or to buy it.
Or customers or incoming customers who then learned like building software is once, operating is it's another. So you need to take care of the dependencies, to update the patches, and that actually whenever you change something, the rest doesn't fall apart. And this is also annoying. So like, this is why we also put it open source, so everybody can work and use it, but don't need to like have the long tail of operating it. And so
I think that is, by the way, a very smart move actually to put it open source and to build up a kind of managed service business model around this. Because at the end, this universal namespace is a kind of critical infrastructure, right? Because you deal with industrial data. So it's a kind of industrial hub. So people, they need to trust you. And I think the best way to earn this trust is when you put actually your business logic open source, so that people really can trace and track and understand like how you deal with the data, or what happens with the data. Let's put it like this. So it's a good move.
I think the open source, I think this shifted. Like when we started like 4 years ago, we were actually mostly confronted with open source is dangerous, open source is for the tinkerers, open source is not something that you could rely on manufacturing on. And this was, I think, a narrative, no blame, but this was what Microsoft did in the early 2000s, where they had like this free GitHub acquisition campaign of against a little bit open source. But I think this changed like quite a lot, because they see how much open source is running circles around commercial offerings in so much spaces, because they're so much faster and more open. So I think this is a good and important shift. And beyond the commercial stuff, like this community is something that's in manufacturing so isolated. So you have ideally perhaps your user forums, like PLC forums. Perhaps you have once in a year, like a convention where you can meet up with other Siemens or Beckhoff users, but there's not this open channel and exchange of information like in open source communities. And this is like the other aspect. So we are like pushing data and software so fast out, so expose it to so many people, and this finds also like feature requests, perhaps some bugs, some issues in using. So a community that gives you feedback is also really, really valuable. And so now, what do you think does BCG makes different? So what they're like, we come from the blue background, if you want. So we worked quite a long time together with another management consulting in their digital factories, and there is a critique against those management consulting firms that they don't like get you all the way there. They give you the PowerPoint slides with a lot of fancy boxes, and then they're out. So what's the provoking question? What do you do differently?
Sure. No, I think we go beyond PowerPoint slides. So just running example, happy to invite you to our BCG automation lab at Aachen Tech University, which is part of our ICO network. So we operate 11 innovation centers for operations globally in partnership with industry players like AWS, but also with academia. And in these centers, for example, in Aachen, we actually build physical proof of concepts. So we support our clients in engineering and implementation work. We mostly focus on, let's say, really cutting edge solutions. I can just give you an example. We are very deep and very much into robotic applications as of now. So we build physical proof of concepts to automate, for example, handling operations which are too versatile or complex for traditional automation solutions. And once we build this proof of concept, then we ship it to the client. So at the line, we integrate this also with solution integrators or with the help of the client into the line. Then in the next step, we would support in design to cost and design to performance, because normally after you've completed such a proof of concept, you showcase the technical feasibility of something. But in the next step of development, you need to tweak on performance and cost of the solution, again, to scale it at the end. And I think we are a very good partner of choice for our customers and helping them along this way. For sure, after the industrialization phase, when it comes to scaling and rolling this out, this is something where we would hand over to a solution integrator, because we are not a solution integrator. So this is actually where our engineering implementation work will end, but it goes far beyond a PowerPoint presentation.
This is really attractive. So you're really eating what you cook, yeah, if you want. So you put something on a PowerPoint, but then also like build it in the field, understand the limitations and the challenges that arise on that, and then also can tweak whatever you proposed, and our future offerings also take that into consideration. I think it's really, really important to see the real world pains. Perhaps this is also our background. So we coming from system integration. So we had a system integrator where we really crouched to the dirty shop floors and laid cables and saw the limitations on networks, saw the limitations on power in some cases, and then specific saw the limitations on data availability. And this gives another perspective on how you position software and advise people.
Yeah, absolutely. One last word. So within BCG, there are not only consultants. So due to acquisitions and a strong investment into our digital capabilities, we have more than 1,000 data scientists. We have hundreds of software engineers, solution architects, and normally we build up really interdisciplinary teams consistent of strategic consultants plus software engineers, data scientists, solution architects. So this is like the typical BCG project as of now is really a heterogeneous team of different skill sets.
And positioned then now in the global landscape. So we are like both from Germany. Germany has a strong manufacturing background. Do you see there are advantages, or based on the current trend, the disadvantages of deriving offerings and software from that market?
I would love to see advantages, yeah, really. But I think as of now, so we need to deal with uncertainty right now, right? So the geopolitical situation is really makes it not easy to navigate in these times. Yes, overall, I think within Germany, we have a very strong footprint in mechanical engineering, in industrial control technology, for sure. We lack a little bit the capabilities when it comes to compute power, to network infrastructure, there is no German or European cloud service provider as of now. I stay absolutely optimistic. I think we can make it, but the time is now. Yeah, we need to invest now. We need to understand the importance. At the very beginning of our conversation, we talked about that everything is turning into software. So we need to understand, and we need to derive the right decisions on this and invest also significant money into these topics to gain competitive advantages. Because what we, I think, also learned over time now is that even in a global world where each and everyone is connected with each other, there might be incidents where you need to build up very strong resilience. And this could be a reason why or a good reason why we should also invest into our own infrastructure.
This is like a really good bridge to one question that I have top of mind that I would like try to ask as many guests as possible. But what do you think changes now on the software landscape? What's the classical stack in 5 years will look now? MES systems, SCADA systems. What do you think will change? Or like being optimistic about implementation speed and actually people to adapt. But what do you wish?
I think even in 5 years' time, there will be a SCADA system and MES systems. Let's say at least for the discrete manufacturing industry. I think a huge shift also in scaling is in the pharma industry, because when we look into new approaches, if you look into cell therapy manufacturing, which is nowadays, let's say, very laboratory oriented, so it's more like a lot size one business. And if you want to scale this, that's a great chance now really to think of from a greenfield, like how do you scale and automate these processes? And the existing, let's say, enterprise science systems and let's say MES systems for these type of businesses, they are much more tailored for laboratory environment, but not for large scale environments. And so I think these are kind of new markets which will in this particular industry. And I think this whole topic of bioengineering and pharmaceutical industry is like a huge chance for existing players, to conquer new market shares.
And I think this is also where currently there's so much growth also happening. And even if the industrial sector in its whole is a little bit like shaking, like the pharmaceutical industry is like growing as fast as ever and even stronger than before. So there will be a lot of change. And they're not as effective, obviously, by the cost pressure from the overseas, because they are like their product and their value gets built in quality and in R&D. So manufacturing is something where they just need to execute fast and flexible. Yeah. So, and then one question that we had at the beginning. So we talked a lot about what OT can learn from IT. To wrap it up, so what do you think can IT learn from OT?
Good question. I think like this, what you need on the OT side is like based on this cycle-based pattern, on a PLC. In the OT world, you cannot deal with likelihoods, so you really need to rely on the strong deterministic behavior. And on the one hand side, maybe this might be a disadvantage when it comes to artificial intelligence, but on the other side, there's also a very strong argument, because deterministic behavior at the end makes sure For example, if you enter an elevator and you press level 3, you're not interested in a likelihood that you reach to level 3. It should always be that you come to level 3. Yeah? So this kind of deterministic behavior is maybe also something we could rely on in the IT world.
Actually, it's super interesting point, because like when we talked about, for example, Kafka introducing as a streaming technology to some of our customers, and it's like about cycle time. What does Kafka guarantee on latencies, for example? It doesn't guarantee it optimizes across a certain like times period, but could be that worst case 5 seconds, and they're like, oh no, 5, but it just happens in once in the trillions of instances, but it could happen because it's deterministic and discrete. So yeah, this is something that IT needs to crack, and where we are like the state machine kings. This is OT, yeah. Really, really important learning to get from there.
Yeah, but maybe it's also okay, yeah, that IT is focusing on the one hand side and OT on other aspects. Yeah, and this is and we need to work on the convergence of IT and OT, where both things actually come together. And there's a good reason why you have different pattern in the IT world than in the OT world, but we need both of them.
Understanding for both sides, I think the key learning on the requirements and capabilities, and then just come closer and don't consider the other side as the enemy, either as a security threat or as the inflexible internal service provider.
Yeah, agree.
So if you're seeking like advice on this topic and really want to understand deeper on what the digital technology can offer, feel free to reach out to Tilman and team. This is a really, really good. So we are also from AWTH, so from Aachen, so we know what they're doing, and it's really, really powerful and impressive what they've built up in the learning factory. So reach out to us, reach out to him, and leave him a visit if you're interested. And that said, Tilman, it was a really pleasure to have you on the podcast. As always, super educated and precise opinions, and I think super helpful for the audience out there.
Thank you, Alex, and team for having me. It was a pleasure.